Good morning, everyone. Today we are going to start the Science Chapter 11, Class 10, The Human Eye and the Colorful World, Part 5. Okay, so let's start. Okay, so in this video, first of all, we will be learning about the scattering of light. So what is scattering of light? Let's understand that first. Okay, let's say that this is any particle. Okay, this is a particle. Okay, now when a light ray will pass, okay, so there is a white ray, so I will make a white one, so it is going through there, right? Now after touching it, it will scatter in different colors, like blue will be more. That the reason I will tell you afterwards. Okay, it will scatter in different colors or in 7 colors. Understood? So this is called scattering of light. Okay, now first of all, in scattering of light, we will understand about the Tyndall effect. So what is Tyndall effect? As we have learned in class 9 also, the Tyndall effect is a scattering of light, or it is a path from where it goes through the particles, okay, or through the space between the particles. In the solution, the space between particles are negligible, so Tyndall effect is not possible. But in colloidal solution, the distance between the particles is there, so scattering of light is possible. So in our atmosphere also, we have nitrogen, oxygen, carbon dioxide, water vapors, argon and other gases. Okay, so nitrogen is 78%, oxygen is 21%, carbon dioxide is 0.03%, right? So this is a composition, so isn't it a colloidal solution, right? So here also scattering of light take place. So the example of this scattering of light is the blue color of sky. So why the color of the sky is blue? This is the phenomena of the scattering of light. So let's see. We know that wavelength of 7 colors. As we know that a white light, when dispersed, it do disperse in 7 colors, right? Vibgyor, Vibgyor. Okay. Now, the wavelength of these are different. The wavelength of violet color is smallest. Indigo bigger than that, then bigger, and the highest is of red. That's why the Vibgyor, when the white light goes through the prism, the violet color dispersed or refract the most, right? While the red color dispersed least, right? So this is the reason, because its wavelength is more and its wavelength is less. Okay. Now the molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of visible light. Okay, so the molecules of air and other fine particles that are in atmosphere have very small size, right? So whichever have the longer wavelength will not scatter, because these are short in size, smaller in size. So the color with smaller wavelength, it will scatter. Okay, now here you can see which of this have smallest wavelength. You can see that violet one has the smallest wavelength. So according to the statement, the sky color should be violet, but no, the color is blue. So let's see the reason of that also. Okay, so V, that is violet, is not visible to us by 2 reasons. First reason, its wavelength is too small, that is smaller than particle also. And second is that our eyes is not sensitive to violet color. It means that our eyes cannot see the violet color, so we see blue color. Now 2 colors left, indigo and blue. So indigo and blue makes a color, a blue, that is the sky color, sky blue color. Okay, so this is why our sky is blue in color. Understood? Now, so as I have told you that when a straight white light goes and scatter through the particle, it will scatter in different direction, and the blue color will scatter the most. So this was the reason why blue color scatters the most. Okay, this will also scatter, but very least. Okay, now the another question is of scattering of light. Example is that why is the color of sun yellow? Why is the color when it is noon? You have seen the yellow color of the sun. Why it is so? Let's see. Okay, so here is our sun. Okay, here is our earth, and here is our atmosphere. Okay, let me write earth, and this is sun. Okay, now what happens when the rays will come, it will be a white light. Okay, so it will be a white light. When the white light will come and strike a particle, it will scatter blue colors. So violet color will scatter, indigo and blue color will scatter. So these three colors are scattered in the particle only. Now we will be left with GROR, means, sorry, not R but Y. Okay, so we will left with green, yellow, orange and red. Okay, so when these color left in the atmosphere, okay, when the particles scatter the blue color, it scattered the blue color. Okay, so these three colors are used. Now only four colors are left: green, yellow, orange and red. So these four colors will mix and forms a yellow color that we have seen of the sun. Okay, so that's why when it comes downwards, the blue color is scattered all around. Only the four colors are left and forms yellow color according to the observer, right? Okay, understood? Okay, now why do we see the red color? The red color of the sun when it is sunset. Why do we see? Or during sunrise also. Okay, so let's see. Okay, so what happens, as in the noon the sun is here. In the noon the sun is here. Now you will have to see the distance. Here the distance is less, while here the distance is much. Right? This distance is less while this is much or more. Right? So less distance is there. That's why we are able to see the mixture of green, yellow, orange and red. But when the sun is very far away from the observer, what happens? Okay, so first the particles scatter the blue color. Okay, so Vibgyor, indigo and blue are used. Now because these are of smaller wavelength, right? Now when they are going, green, yellow also scatter. Okay, so because they have less wavelength than orange and red, right? And when after covering so much distance, we are able to see the red and yellow, sorry, orange and red mixture, right? Okay, so when the orange and red mixes, it will be giving like this. Okay, this is not accurate but somewhat. Okay, now here's experiment also to show that why it is red in color. So first you have to take a source of light. As for source of light, after that you have to take a convex lens, right? And after, when the rays will go through it, it will go parallel. Why? Because in the chapter 10 we have learned that when the light ray will go through the focus, this is the focus, when go through the focus, it will go parallel to the principal axis after going through the focus. And here it is happening here. Now what happened? You have to take a beaker. In beaker you have to take 2 liter of water. Okay, you have to add 200 gram of sodium trisulfate. Okay, and then you have to add 1 to 2 ml of sulfuric acid. Okay, now this is our setup. So now you have to take a cardboard, make a hole. Okay, then very less light ray will pass through it. Now it has become colloidal solution after adding so much of thing. Now it will go through the hole, and after we have to take the convex lens again we will take, and it will converge to a point, and that point will be red in color. Okay, so from this activity what we see is, when the light will go through this white, right, so it will scatter the blue color. So on the 3 sides of the beaker, that is front, back and front, this is left and this is back side, you will see the blue color. And in the front side, when the light ray will be going and after covering the distance, it will be in red in color. Okay, so this is why we see the red sun at the sunset. Okay, so that is for today. Thank you.